Hello everyone, I hope you all are fine, and today we are over here discussing the solution of practice problem 2. So our question is, this is our question. So the question states, prove that GCD of m comma n upon n into m choose n, n choose m is an integer. So where m is greater than equal to n is greater than equal to m and m is greater than equal to 1. Okay, so how we can prove this? So over here I think you guys know this is mcn. Okay, let me show you guys. This is mcn. No, sorry, that is NCM. Yeah, NCM. That is M choose N. So the formula, so first let me write the formula of M choose N, that is equal to NCM, that is equal to N factorial upon M factorial into N minus M factorial. Okay, so this is the formula of this. Yeah, so now we can expand this expression, so we can call this expression as s, that is equal to this. So s is equal to GCD of m comma n by n into n factorial by m factorial m minus n factorial. Okay, so now we try to do some random manipulation or exploration, just doing everything that is available. So the simpler, so now s is equal to GCD of m comma n by n into n. Okay, so we can cancel this, so n minus 1 factorial by, now we can do m into m minus 1 factorial into m minus n. So what is the thought process? So the thought process is that this terms get cancelled out. Okay, this term get cancels out. Which term? So this term cancels and this become n minus 1 factorial. So the thought process is that if I take out one m from this will become m minus 1 factorial, and now I can clump these three terms and make n minus 1 c m minus 1. You can see, wait, yeah, this and m minus 1 factorial, n minus 1 factorial, yeah, these three terms. Okay, so now let us move on. What else we can do now? Okay, so now we need to prove that now s is equal to GCD of m comma n by m into n minus 1 into c m minus 1. Okay, so now we need to prove that this belongs to Z. So how do we do this? So now we will over here use something that is called Bézout's lemma. Okay, I hope you guys have heard about this. Okay, so Bézout's lemma is Bézout's lemma. So that states that GCD of m comma n is equal to mx plus ny for some x comma y belonging to integer. Okay, so the solution of this equation exists. So we can write GCD as of this form. So we will use this, and what happened? Okay, yeah. So now we will replace GCD with this. So S is equal to mx plus ny by m into n minus 1 c m minus 1. Okay, so now our S is equal to x into n minus 1 c m minus 1 into n by m y into n minus 1 c m minus 1. So now we see that this term is an integer. So to prove that y into n by m into n minus 1 c m minus 1 is an integer. Okay, so now how do we prove that? So it seems like this term, for this to be an integer, it fully depends on y. Okay, but it doesn't. So we just try to expand this n minus 1 c and m minus 1. So we see that this term is just ncm, you see. So the second term is equal to y into ncm, that belongs to integer, hence proof. Okay, so this was the solution to our problem. So in this problem we have used Bézout's lemma. Hope you all like the problem and the solution, and you find this video helpful. Ending the session. Thank you guys for watching.